So what happens when we add two opposite vectors is that we get the resultant is a zero vector or a null vector. Basically, they eliminate each other because, and I'll just kind of show you what would happen, is that if I were to draw A and then the opposite one going in the other direction, and I were to draw, let's say I'm trying to do the triangle method, the tail, the head of A and the tail of negative A would be here, and we would go back over it. Well, if I tried to reconnect the head and tail of my vectors, there's nothing there. So this is a null vector. Okay, I do have a couple of applications just to kind of show you what this would actually be for, okay? Again, we have an airplane problem here, and so it says, an airplane is flying with an airspeed of 310 knots in a direction of 50 degrees north of east. Okay, so we've got an airplane that's flying 310 knots, 50 degrees north of east. And then we have, it says, a 78 knot wind is blowing from 55 degrees north of west. We want to determine the resulting speed and direction of the plane, because the plane is now fighting the wind. So it's going to turn a certain direction, but then, so here's the plane going, and here comes the wind. Even though the plane is trying to stay that way, the wind is going to push it. So that's what's going to happen. So let's see, we've got the airplane. Let's look at the airplane first. And so I have my north, south, east, and west. And it says the plane is flying at 310 knots in a direction of 50 degrees north of east. So I'm looking for my pencil, hang on. And I think I'm running out of lead, of course. I'll just use a different color. All right, we're gonna go 50 degrees north of east. So we wanted to start at the east, and we're gonna go towards north, and we're gonna go 50 degrees. So if this were 45, we'd go a little bit more. I'm gonna say that's about 50 degrees. And then I wanna represent 310 knots. So let's say I represented 1 centimeter as I don't know, 100 knots, okay? Well, that means that 3.1 centimeters would be equal to 310 knots. So we'll start with that. So this is going to be my scale. And I want to measure out 3.1. So this is my vector for the plane. I'm just going to call this vector A for airplane. And I'm actually going to use the triangle method here. And then I have the wind. And so instead of trying to draw them separately, since I know I'm going to do the triangle method and I'm going to take the head of one and put it on the tail of the other, I'm going to make another little north, south, east, west right at the end of my vector. It's kind of a sneaky trick. And this one's going 55 degrees north of west. So we're starting from the west and we're going towards the north. So this guy went this way, 50 degrees, and this one is going this way, 55 degrees. So if this were 45, I would say it would be about right in here. And then the length of that vector, you have to think about this for a minute. If 1 centimeter is 100 knots and I'm going 78, then I'm going to go 0.78 centimeters would be 78 knots. So not very long here. So almost 0.8. Okay, and then here is my resultant. My resultant is from here to here. And so what I would want to do is I would want to measure this angle. Kind of depends on how accurate my guessing was here. Looks like it was pretty good on the 50. So this is at about 65 degrees. So this is for the resultant. My resultant here is in purple. And so it's 65 degrees north of east. And then the magnitude, the length, is going to tell me how many knots that is. And so we'll measure that. It looks like it's really close to 3.7 centimeters. So 3.7 centimeters would be about 370 knots. And so we can then figure out where the plane needs to be. So if you can imagine, if this is actually where we wanted to go with the plane. This is the direction it's going, taking into account the plane itself and the wind. So that means we still want to point the plane this direction. But with the wind, that's going to cause the plane to move a little bit, and that's how we're going to get to our destination. So basically, we start out, we're overcompensating, but we know that the wind is going to come along and put us in the right direction. All right, one more. And this was about rectangular components, and it says are vertical and horizontal. Heather is pushing, so here's my vector right here. It really should go, I guess, this direction, because it looks like he's pulling with some force here. And so that's at an angle. This is my x-axis, this is my y-axis, so you can see we have a right angle, in which case we could use Pythagorean theorem, which is a squared plus b squared equals c squared. So this is my horizontal component, and this is my vertical component. So we'll see how it is affected right here. Heather is pushing the handle of a lawnmower with a force of 450 newtons at an angle of 56 degrees with the ground. So she's pushing it, which is why the vector is actually going down towards the mower. So here she is. And she is mowing the grass with their hat on because, you know, sun protection and all. Okay. So that's her force is 450 newtons, and it's 56 degrees with the ground, or with the horizontal. Draw a diagram that shows the resolution of the force that Heather exerts into its rectangular components. And so it would kind of look like this, where we've got our angle is 56, and that's 56 degrees. And then we have 450 newtons. And then you've got your x value and your y value, even though this is the direction of the vector. Find the magnitude and the horizontal and vertical components of the force. And so what we want to do is we want to set up a little sine and cosine. And we've got sine of theta is opposite over hypotenuse. And so in this case, I would take sine of 56 degrees is equal to y over 450. And so 450 times the sine of 56 is equal to y. And I want to get my calculator. Make sure your calculator's in degrees. And so y is about 373 newtons, because it's a force. So how much force is going down, basically. Okay. And then my horizontal force pushing this way, that's going to be a cosine. So cosine of theta is adjacent over hypotenuse, which is going to give me cosine of 56 is x over 450. And so 450 cosine of 56 is equal to x. And that's going to give me, my x is going to be about 251 newtons. So this is actually my vertical component. And this is my horizontal component. So when you're pushing the lawnmower, you're not just pushing diagonally, you're pushing down and forward at the same time. All right, thanks for listening, and I hope you learned something about vectors.